Yeah, it's a warning. So it's kind of like when you go into like yeah, so like when you eat like a medicine, it says warning, please be careful, only eat once a day. Okay, this one has a warning. This requires strong algebra skills and attention to detail. Please take it slow and watch your calculation. You are now warned. Okay, I think you guys are pretty good, but just please be careful. All right, let's review Algebra 2. Can you combine them into one fraction? No. Of course you can. Of course you can. Of course you can. It has to have the same denominator. So the least common denominator is both of them, right? So we need to multiply the one on the left by x plus 3 over x plus 3. And we need to multiply the one on the right by x minus 4 over x minus 4. So we need to combine them into one big fraction. You guys still remember this? Yeah. Okay. You have to, because this is just basic Algebra 2 skills that you're going to use forever. Okay, so go ahead and multiply them together. You're going to distribute and then add them together. Make sure they have same denominator. And then write your answer. We are good. Answer is 5x plus 1 over x squared minus x minus 12, right? Okay, that was so last year. Now, we are going to decompose. So now, from this fraction, can you figure out that it's like this? Not yet. Okay, you will today. So I'm going to show you how it's done. I'm going to get rid of this one. That one's too complicated. We're just going to rewrite that problem. 5x plus 1 over x squared minus x minus 12. All right, so what we're going to do is we're going to play this game. So Cammie's like, oh no. Okay, so this is our second game this chapter. The first game was row operation. This game is the partial fraction game. All right, so I'm going to tell you the game rules. You don't ask me why. You just play the game, okay? Because if you ask too many why questions, you can't play the game. Okay. All right, I'm going to just tell you the rules. And then I know you guys will be like, what? Well, it doesn't make any sense. I know. That's why I tell you right now. Don't ask. Don't complain. Don't ask any questions. I'm just going to tell you the game. Step 1, number 1 of the rule of the game. The degree of the numerator has to be less than the degree of the denominator. Okay, the top has to be smaller in degree than the denominator. That is the first rule of the game. Okay, second rule. We want to factor the denominator. All right. So I'm going to write this problem on the bottom. So 5x plus 1 over x squared minus x plus 12. Okay, so step 1, check. Is the numerator degree smaller than the denominator degree? Yes. Okay, good. Step 2, factor the denominator. So we need to factor this. I think it was a minus 12, right? I wrote this wrong? Yeah. I can't subtract, so I cannot. Sorry, I should be minus. All right, so far so good. Step 3 is where it gets really confusing, so please just follow along. Step 3 says every one of those factors gets its own fraction. X minus 4 plus x plus 3. So each factor gets their own fraction with a denominator. All right, step 3, there's a second part to step 3. Step 3 says, whatever the denominator is, we're going to put a placeholder in the numerator that is 1 degree less than the denominator. Okay, x minus 4. What is the degree of x minus 4? 1. What's 1 degree less? 0. So what kind of things is like x to the 0? A number, a constant, right? So we need to put a constant on the top. And we don't know what number it is, so we're going to put something as a guess. Not a number, we can't put a number, so we're going to put a variable, a. So I don't know what a is. I'm just going to put a there so I can solve a later. It's okay, we'll figure out what a is later, but for now, just put a. All right, next one, x plus 3. X plus 3 is first degree, so then on the top it's going to be 1 degree less, which is going to be a constant. So what should we put here? B. Okay, it has to be a different letter because we can't make them the same number. All right. Okay, the next thing we're going to do is just combine them together into one big fraction. Again, so you just did that. Okay, so go ahead and do that and just combine them into one big fraction. Make sure you distribute a and b. Okay, so let me just help you. A times x plus 3 plus b times x minus 4. The denominator is common, so it's x minus 4, x plus 3. Okay, so you need to simplify this part, so you're going to distribute, and then I'll tell you what to do next. So just go ahead and distribute it, and then I'm going to help you. Okay, so we get to this part. Ax plus 3a plus bx minus 4 over x minus 4 times x plus 3. Oh, sorry, 4b, yeah, thank you. Okay, this is equal to 5x plus 1. Remember, we're trying to figure out what x is, what a is, what b is, right? So the denominators are the same, which means the numerators have to be the same, right? So 5x plus 1 is equal to ax plus 3a plus bx minus 4b. All right, this is where it's kind of interesting to do this. So basically x, we just kind of ignore it. What we are looking for is we want to solve for a and b. So in front of x is 5. So 5 has to equal all the ones that have numbers in front of x.
A plus b equals 5.
Yeah. So all the x's are together. So 5 has to equal a plus b. Yes? Constant, the 1. 1 has to equal on the right-hand side whatever that doesn't have an x next to it, which is the 3a and the minus 4b. All right, how do we solve a and b? Just solve it. Right, just solve it. You can use system of equations, so elimination or substitution, but you can also use matrix, right? So we can write this as 1, 1, 3, negative 4 times AB is equal to 5, 1. So think of AB as my new variable, and I'm trying to solve for AB. So I can write this as the coefficient matrix, the variable matrix, and the constant matrix, and then just solve. Okay, if it doesn't tell you you have to solve by matrix, you can just solve it this way. Algebraically. Okay, so go ahead and figure out what A and B are. All right, A and B are, is it 2 and 3? 3 and 2. Yes, no? Double check. 3 and 2, yes. Now that is not the answer. The answer is 3 over x minus 4 plus 2 over x plus 3. Once you find a, b, you have to put it back into the partial fraction. That's what we want. We want to figure out if we decompose it, how does the fraction look like? So once you find a and b, you gotta plug it back into the fraction, okay? Okay, let's have you try one, and then we're gonna go to harder questions. The rule is when something is different. Okay, so for example, when the denominator is a repeated factor, meaning this is a repeat of a sum factor, what you need to do is you start with that factor at the lowest degree, x plus 1. And then you add the same factor, but to the second degree, and you keep going until you meet the highest degree. For example, so this is where it gets really crazy. Okay, for example, if you have, let's do x plus 2 to the fourth. You're going to do x plus 2 squared, x plus 2 cubed, and then x plus 2 to the fourth. Okay, so this is how the game is played. Please don't get too frustrated on why is it like this. This is just how it is. When you have a factor that is repeated, you start from the very bottom, 2 powers, 3 powers, 4 powers, whatever, until you get to the highest power. Okay?
Then we put A, B, C, D for this one.
Ah, this is the part that is confusing for everybody. Okay, so first one, x plus 1, what should be the coefficient on top, or the numerator? A. X plus 1 squared.
X, B.
Ah.
Oh, A squared? X.
B. Why? Because this is why it gets crazy. You don't care about the square. You only care about what is repeated. The one that's being repeated is a linear, so you go 1 degree less. Okay, let's try this one. This bottom one. X plus 2, what goes on top? A. And then x plus 2 squared? B. And then x plus 2 cubed? C. And then x plus 2 fourths? D. Okay, so we only care about that factor that's being repeated, not the power. Okay, now, the other weird rule. Okay, if you look at this one, the denominator is x times x squared plus 1. Can I factor x squared plus 1 without getting imaginary? No, it's unfactorable, right? The way we write this is x squared plus 1. Anything you cannot factor anymore, you rewrite it as a factor. All right, what is the numerator that I should put for on top of x?
A.
Good. All right, x squared plus 1. This is a little tricky.
X.
Yeah, I need to put x because it's 1 degree less, right, within the denominator. The degree in the denominator is 2. 1 degree less is x. But I can't just put an x. If I put x, I'm assuming it's 1. Bx. However, there's one more rule. You write plus c. So basically, continue to decrease the degree until you get to constant. This is where you say, don't ask why.
No.
Okay, don't ask why. All right, so, for example, I have a cube I cannot factor. I have a cube I cannot factor. First of all, what would be the degree in the numerator? Squared, right? squared. So help me write the whole numerator. Ax squared plus bx plus c. Yeah, there you go. So that's how you do it. Okay, so we're going to play the game for a little bit. So what I'm going to do is have you just write out what it should be for all the other problems. Okay, and then tomorrow we're going to solve the harder ones. But today we're just going to write this whole thing out. Okay, so let's look at the next page. Okay, next example. This one. Rule number 1. Check that the numerator has less degree than the denominator. Does it? Yes. Number 2, factor. Make sure you factor the denominator. So go ahead and do that. So once you factor, write the skeleton. So this is x minus 5 and x plus 3. So what you want to do is write the fraction. So what would be one of the denominator? X minus 5, and then what would be the other one? X plus 3. All right, what's the coefficient for the first fraction? A. And then the second one would be B. All right, so go ahead and solve A and B and then rewrite your whole partial fraction and let me know when you're done. All right, the answer is 3 over x minus 5 plus 2 over x plus 3. All right, this is all nice and easy, except I'm going to tell you there's another rule. Let's try this one. This is on page 14. Let's have you try this one. Factor first, and then write out what you think is the partial fraction, just the coefficient part. When we factor this, we get x times x minus 2 squared. So that's going to be x minus 2, x minus 2 squared. A, B, C, because they're all linear factors or a repeat of linear factors.